if we have a list of integers, let me call it ints, is equals to a new array list. And inside this list, ints.add, I have a number, I could have another integer, I could have another number there. If I wanted to remove elements from this list of ints, I can call ints.remove, remove the element, and I can say remove 1. I could also call ints.remove, and you can see we have remove last for removing the last element. You can also use ints.remove first to remove the first element. But there's a variant. We've already explored this and we know how they work. This will remove 1. This will check what is the first element. This will remove the first one. So this will check the last element. This will check for the first element and it will remove it. But there's a variant we're not able to play around with, which is this remove if. And with remove if, you'll notice it's accepting a predicate. And imagine this predicate like our drivable. It's similar to drivable. Yeah, we are passing drivable to the global driver. So the same with the remove if, it receives a predicate. And a predicate is basically just a way of representing a condition, a true or false state. So a predicate can be true or false. It's like a condition, it's like a Boolean. And it will use that Boolean value, that conditional, to decide whether to remove the element. The different thing with this predicate, or the unique thing with this predicate, is that it's a functional interface. Okay, you see, just the same way we're using add functional in our code, this is also using add functional annotation, and it's an interface. So it's a functional interface. Of course, it's using some generics. We've seen that, so this shouldn't be surprising. And it has one abstract function, which is test, and test just returns a Boolean. So since we know how to use functional interfaces, let's try and use this predicate. We know it has this single function, which means we can use it as a lambda. So if we go back to our remove if, we can say can say predicate. Again, predicate is just like drivable. So it's just like this. Drivable, drive shack, or this other one. Except now we are using predicate. So predicate, this one is working on integers, and predicate is equals to, we know it's a functional interface, so we can use lambdas. So we can use that lambda there, and it's supposed to, let's look at the predicate again. So the predicate receives the value and returns true or false. So it can receive an int, which is a number, and it can return true or false. So for instance, this is a qualifying predicate. Perhaps if I want to only return true if n is greater than 1, so I could say only return true if n is greater than 1. So this forms a predicate. And just like we did with the global driver here, we can pass that predicate to our if function. So if we pass it to the remove if function, what will happen inside the remove if? It will check as it runs through the numbers in the list. Remember, we are calling this on this list. It will check, is 1 greater than 1? If 1 is greater than 1, remove it. Is 2 greater than 1? If 2 is greater than 1, remove it. If 4 is greater than 1, remove it. So this is the condition that will determine whether an element is removed from this list or not. So let's try and use a simple condition, like let's say we use equals. So if n is equals to 1, we remove. And then let's print the values in the list after removal. So let's see what happens. So before removal, we'll have these elements. This is before removal. We'll have these ints. And then after removal, we'll have this. So let's run it and see. So we see before removal, we have 1, 2, 3, which is all the elements, 1, 2, 3. After removal, we'll see we have 2 and 4. 1 is removed. And why is 1 removed? Because it is equals to 1. Let's say we want to check for every number that's greater than 2. Remove any number that's greater than 2. Any number that's greater than 2 here is 4. So if we run it, if we run that, we'll see that before removal we have 1, 2, 4. After removal, we are left with 1, 2. Because 4 is greater than 2, it's removed. The same way we can say any number that's greater than 1, remove. So if we run this, we'll see that before removal we have 1, 2, 4. After removal, we are left with 1 because 2 and 4 are greater than 1. So this is an example of how you can use functional interfaces and functional programming to utilize some APIs that are provided under the Java Collections framework or Java Collections library. So yeah, this is just one example. We'll look at additional examples later on that capitalize on this idea of lambdas inside the Java Collections framework.